are on page, where is it? Page 425. 425. I would like to start with the average value, 426. And then we'll come back to these problems. So let's illustrate this formula with find the average function value over the given interval. Anything from 34 through 44. Anything you wish. To find the average value.
39.
39. So let's look at 39. So in 39, we have f of x equals x squared plus x minus 2, and the interval is 0, 4. Very good pick. Easy, straightforward question as a warm-up. Very good. The average value is 1 over 4 minus 0, the integral from 0 to 4, from the function x squared plus x minus 2 dx. We're going to find the antiderivative, 1/4 in front, antiderivative, and evaluate it from 0 to 4. Can anyone give us the antiderivative here so we can put it in?
X to the power of 3.
Yes, awesome. Yes, plus
X squared over
2, very good, and minus?
what is that? Minus 2?
Yes,
2x.
very good, awesome, great. Of course, again, it's a polynomial. When I plug in 0, only for polynomials, careful, I will get 0. So all I need to do is just plug in 4. 1/4 will stay outside patiently. 64 over 3 plus 16 divided by 2, which is 8. And minus 8, awesome. So I have 1/4, 64 over 3. I will simplify. And I get 16 thirds. This is the average value of this function on the given interval. Good. Do you think we need another example? Oh, where are you guys? I lost you. Okay. Do we need another example for the average value of the function?
Why do we need average value? What does that mean?
Excellent. Very good point. So tomorrow, between 6 a.m. and 10 a.m., I have the temperature function, and I would like to determine the average temperature. What would be the average temperature between 6 a.m. and 10 a.m.? And I am given the temperature function, because if I don't have the temperature function, I can't determine the average. So if this x squared plus x minus 2 is the temperature function, and I'm asked to find the average temperature between midnight and 4 a.m., this is what we just did. It's 16 divided by 3 degrees Fahrenheit in this example.
Thank you.
Perfect question. Thank you. So, assuming that this is the temperature function, assuming, let's say, this is midnight to 4 a.m., or if you want noon till 4 p.m., whatever you want this to be, when I determine my calculation, I'm telling you that between these two, the average temperature, the average value of this function was 16 divided by 3, whatever measurement unit, degrees Fahrenheit. Good, awesome. Okay, do we need another example from this? If not, I'd like to go back to other examples, to the previous page. Okay, no one said anything. Good. So now let's look at areas between curves, but first I would like us to choose finding the area under the graph, because this is one of the properties we just looked at, between 1 and 6, first of all, between 1 and 6. So let's illustrate how we determine the area under graphs for a piecewise defined function, because we had that a long time ago in the graph and everything. So
Number 3.
number 3. So we want to start with number 3. In number 3, we have g of x, which is the, it's not the integral just yet. Okay, it's negative x squared plus 5 for less than or equal to 0, and x plus 5 for greater than 0. And notice here we have the interval, negative 2 to 3. So find the area under the graph. Fine. Well, I know the area will be the definite integral between negative 2 and 3 from g of x dx. But I have to think that on one interval, I have a function, and on a different interval, I may have a different function. In my example, it's the same function, but it may or may not. And it's not. For less than or equal to 0, I have this function. For greater than 0, I have another function. And 0 is somewhere between these two. So this is like 0, and this is negative 2, and this is 3. So what should I write? How do I proceed? Well, obviously, I have to use two integrals. One for this function between negative 2 and 0 from this function. And then from 0 to 3, 0 to 3 from this function. If this is understood, we'll continue finding it. If it's not clear, please say so I can explain again. Is this okay, everyone?
Can you go through it one more time?
Yes. So see, this function is defined between negative 2 and 3, but not by the same piece. If I use the interval, let's say 1 to 5, I'm only using this function because the interval 1 to 5 is here. So I will have the integral from 1 to 5 from x plus 5 dx. But this is tricky a little bit because they want us to find the area between negative 2 and 3. But this function has two different pieces. One piece to the left of 0 and another piece to the right of 0. So to the left of 0 from negative 2 to 0, I have to use this function. But from 0 to 3, I have to use this function. Does it make sense? Is it clear or not?
Yeah, that makes sense.
Better, everyone? So once we understood that, the rest is easy. The antiderivative of this is negative x to the third over 3. You already told me for all of those. From negative 2 to 0, plus, you already told me that that is x squared over 2, plus 5x from 0 to 3. We check again if you want. When I differentiate this, I get that. When I differentiate this, I get this. When I differentiate this, I get x. When I differentiate this, I get 5. Now I have to be very careful because to evaluate this further, I have to plug in 0. But that is 0 minus when I plug in negative 2. So this will be negative 8 with minus in front 8/3 and minus 10. So when I plug in 0, I get 0 minus when I plug in negative 2 plus when I plug in 3, I get 9/2 plus 15. Luckily, when I plug in 0, I get 0. And sorry, now I have to perform these calculations. So I have negative 8/3 and plus 10 and plus 9/2 and plus 15. 15 plus 10, 25 minus 8/3 plus 9/2. I know that the least common denominator is 6. This one needs a 6, this one needs a 2, and this one needs a 3. So this is 150, this is minus 16, and this is plus 27. So 27 minus 16 is 11, so 161/6. So the area under the graph of this piecewise defined function, specifically between negative 2 and 3, is this number. Any questions?
Why did you have those zeros in that equation up there?
Very good. Awesome question. Let me go back for a second. When I plug in whatever, minus when I plug in the lower limit. So when I plug in the upper limit, I get 0. Minus when I plug in the lower limit, I get this.
Okay.
Plus when I plug in the upper limit, I get this. Minus when I plug in 0, I get 0. Just to make sure that we don't skip anything. Is that better?
What gonna be if I misplace 0 and minus 2?
If you swap these,
Mm-hmm.
very good question, awesome. So here's the property. The integral from a to b from f of x dx is the opposite of the integral from b to a from f of x dx. So you will get the opposite answer. Very good question.